So we are going to look at normal distribution applications. And our first example says the average annual salary for all U.S. teachers is $47,750. Assume that the distribution is normal and the standard deviation is 5,680. Find the probability, that's the key word, find the probability that a randomly selected teacher earns between 35,000 and 45,000 a year. So let's look at A. So the key is you're looking for a probability. And if we look at our notes, that means we're going to use norm.dist on Google Sheets. And since it's between, we're going to use this setup. Equals norm.dist with the right bound minus norm.dist of the left bound. So use norm.dist. And our first one is going to be equals norm.dist of the right bound, which is the larger one, 45, 1, 2, 3, comma the mean, which is 47, 750, comma the standard deviation, which is 5680, comma true. Okay, and then minus norm.dist of the lower bound, which is 35,000, comma the mean, comma the standard deviation, comma true. Okay, all right, and so let's go take that, put that over here. So this is, okay, and that gives us 30.17% if we round it down. Okay, yeah, 30.17% chance. Okay, so equals 30.17% chance of teachers will earn between 35,000 and 45,000. Okay. All right, B, more than 40,000. So again, this is norm.dist because they're asking for probability. And more than 40,000. So that's more than. So the probability that x is greater than a value is this 1 minus norm.dist. Okay, so equals 1 minus norm.dist of the right bound there, or the left bound, 40,000, 2, 3, comma, the mean, which is 47,750, comma, the standard deviation, which is 5680, and then true. Okay. And let's go see what that equals. Okay, so 91.37%. All right, so that's number 2. All right, next question. The average annual professor's salary at a doctoral level at a private independent institution is $159,964 for men and $147,702 for women. Okay, so they give you two averages. Consider the women's salaries. That's important. Assume that they are normally distributed with a standard deviation of 8,900. So let's look at this. Men's average equals 159,964. And women's average equals 147,702. Okay. And then they give you the standard deviation, and that's for the women. So women's SD equals 8,900. Okay. So they're asking, what is the probability? So that's the key. You're looking for a probability. If you want to find the probability, that's going to be norm.dist. Okay, so use norm.dist. So this equals, and it's going to be a probability that they make more than the men's average. So they're saying, what's the probability that it's more than this number? So this is more than, it's a right tail. So we're going to use 1 minus norm.dist. So equals 1 minus norm.dist. Okay. The average we're going to use, or they want to know the x value is 159, the men's average. Okay. Because this average standard deviation pair is for the women. So that's what's got to go here for the mean and standard deviation of norm.dist. 147702. That's the average for the women. The women's standard deviation is 8,900. And it's easy to get the two averages mixed up because they give you two averages, but only one has a standard deviation that pairs with it. So that's what you use in norm.dist. The other one is the x value they're checking to see is it more than. All right, equals, and let's see what that equals. Paste that in, and that's going to be 8.41%. So not very likely for women to make more than men. Only about 8% of them are expected to make more than the men's salary. Okay. Okay. All right. Next one. To help students improve their reading, a school district decides to implement a reading program. It is to be administered to the bottom 5% of the students in the district based on the scores on a reading achievement exam. So bottom 5%. If the average score for the students in the district is 122.6, find the cutoff score. So they're asking you to find a score, not a percent this time. Find a score. So that means we're going to use norm inverse because we're given a probability, the bottom 5%. So that means it's left-sided. Find the cutoff score. So a couple things. 5%. So we're looking at the probability that x is less than some a and it equals 5%. Okay, and we want to find that a. So we're going to use, oh, and the mean, we need that. Mean equals 122.6. Standard deviation equals 18. So use norm.inverse equals norm.inverse, and it's already left-sided, so we don't need to change the probability, so we just put in 0.05. Okay, comma the mean, which is 122.6, comma the standard deviation, which is 18. And that should give us our answer. Okay, so the cutoff for the bottom 5% is 92.99, and since they give us the mean as one decimal place, we will use the same practice. So let's round that down to one decimal place. 93. Okay, is the cutoff score for the bottom 5%. That means if you got a 93 or lower, you're in the lowest 5% of people scoring on this test. It means 95% of people are expected to score above you. All right, last one. The average age of Amtrak passenger train cars is 19.4 years. Okay, so they give us a mean, 19.4. If the distribution of ages is normal and 20% of the cars are older than 22.8 years, oh, interesting. Okay, so the probability that X is greater than, older than 22.8 equals 20%. Okay. Find the standard deviation. So, well, it's confusing because you're given an X and you're given a probability. So that means, but they say find the standard deviation. So that means we can't use norm inverse or norm.dist because both of those require a standard deviation. So the only thing that relates an average with an X value and the standard deviation is the z-score formula, okay, which is right here. So let's copy that. So we're going to have to use this z-score formula somehow. Well, in order, we know that we can use norm inverse to get a z-score. We just need to make sure we have a left-sided probability. Okay, so there's going to be two steps here. Step 1, find z-score using norm.inverse. All right, so equals norm.inverse. We need the probability. Well, they say 20% are older, so we need a left-sided probability. 20% or older is right-sided. Notice it's x greater than. So to get left-sided, we do 1 minus 20%, which is 80%. So we can put in 0.8, comma. We're going to find a z-score, so we use the standard normal distribution of 0, 1, and then we'll see what that equals. So let's go over here. Step 1. Okay, that's our z-score. So 0.84. Okay, step 2 then is to find the standard deviation. Okay, and we can plug what we know into the z-score formula. So 0.84 equals x. Well, we know that x is 22.8 minus the average, 19.4, divided by standard deviation, or sigma. Okay. So that means 0.84 equals 22.8 minus 19.4. That is 3.4 divided by the standard deviation. So standard deviation equals 3.4 divided by 0.84. So SD equals, and let's do that over here. So that means 3.4 divided by that z-score. So step 2, I forgot to initiate my formula, 3.4 divided by the z-score. Boom. So that is a standard deviation, 4.04. Okay, and that is the answer. The standard deviation for this is 4.04.